In this video, we're going to be looking at classifying polynomials. There are two different ways that we're going to do this. First is by degree. The degree of a polynomial is its highest exponent. The highest exponent. This is the highest exponent specifically of x, or our variable. So, for this first one, we're looking at our x's. The highest exponent is 5. There is an exponent of 2 here. There isn't an exponent written of x for that last one because it's a constant. So the degree is just going to be 5 because that's the highest exponent of our x. Looking at the second example, we're looking for the degree. The degree is going to be the highest exponent of x. The degree here, or the exponent here is 2. The exponent here is 4. The exponent here isn't written, but we know it's 1. And then there isn't an exponent here because there is no x. So the degree here is going to be 4 because 4 is our highest exponent. For this last one, we have to look a little bit carefully here because, again, we're looking for the highest exponent. That's the degree, is the highest exponent. But because the only x here doesn't have an exponent, we know that it's automatically a 1. Remember, it's a 1 if the exponent on x is not written. Those are the most common examples that we'll see. But sometimes we'll have an opportunity or a problem that has more than one variable in a polynomial. And in that case, what we have to do to determine the degree is add up the exponents of each term. So we'll talk about terms in just a second, but I'll show you here real quick. This is a term, this is a term, and this is a term. So for this first one, we look at all of the variables listed. We have 2 different variables listed. Notice the exponent here is 2, the exponent here is 1. So the total exponent that we would say for this first term would be a total of 3 because this one has 2 and this one has 1. For this one, notice we again have 2 variables. The exponent here is 2, the exponent here is 2, so total for this term it's 4, which means that the degree of this polynomial is 4. The highest exponent is 4. Now, that's because for each term, what we have to do is add those exponents. That's only if you have more than one variable. Looking at this next example, we're going to start with this term. So this is a 2. Here on the y, it's a 1. Here on the z, it's another 1. So if I add all those up, I get 4. So here I have 4. Notice this is the only exponent, so it's 3. The degree here would then be 4. Right? Because 4 is bigger than 3. It's the highest exponent when we combine all the exponents in each term. And for the last one, notice here we have 3 different exponents. This one, or 3 different variables, excuse me. This one has exponent 1, this one has an exponent 1, and this one has an exponent of 1. So total, that gives me 3. Notice there are no variables here because 10 is just a constant. So my degree is going to be 3. So when you have more than one variable, it's a little bit different. You have to add up the exponents in each term. But most likely you're going to see the examples that we did for the first piece. So let's talk about terms. I've mentioned them before, but a term is it can either be a single number or variable, or numbers and variables that are multiplied together. The easy way to determine if you have a term is they are separated by a plus or a minus sign. So let's look at this first example. We have 1, 2, 3 terms here because they're separated by those plus and minus signs. For this next one, there are 1, 2, 3, 4 terms. 4 terms. Terms are separated by plus and minus signs. And for the last one, we have 1, 2 terms. Terms are separated by plus or minus sign. Doesn't matter if you have more than one variable for terms. It's still the same thing. They're still separated by plus or minus sign. So here we have 1, 2, 3 terms. For this next example, again, we're just looking at where they're separated by the plus or minus sign. We have 1, 2 terms. In the last example, 2 terms again because they're separated by the plus or the minus sign. So once we understand degree in terms, we can use special words to denote different types of polynomials. We can classify them by degree and by terms. So in the same way that you can describe somebody by both their height and weight. They're two separate things, but they're both a way of describing somebody. So in this case, we are going to classify polynomials two different ways, either by their degree or by their terms. So the first thing, a linear, which we've already talked about, linear functions like y equals mx plus b, the degree is equal to 1. So an example of that would be like 4x plus 2. And maybe you can kind of see that looks like y equals mx plus b, right? This is the slope and this is the y-intercept. The x here doesn't have an exponent, which we know that means the exponent is 1. For a quadratic, the degree is 2. So we call a polynomial a quadratic if the degree is 2. So an example of that could be maybe 4x squared minus 5x plus 11. See how the highest exponent here is 2? That means it's called a quadratic. And for the last one that we're going to talk about in this class, a cubic. A cubic, the degree is 3, which maybe you could have already guessed. But that ends up being like 11x to the third plus 10. Doesn't really matter what the other terms are there. It just, as long as you have a degree, the highest exponent is 3, it's going to be a cubic. So the other way that we can describe polynomials is by how many terms they have. It is considered a monomial if it has one term, a binomial if it has 2 terms, and a trinomial if it has 3 terms. If it has more than that, more than 3 terms, we would just call it a polynomial. Now that doesn't mean that a monomial, binomial, and trinomial are not polynomials. These all are polynomials, but we don't have a special name when we're talking about greater than 3 terms. So an example of a monomial could be like 4x squared, right? There's just one term there. It's not separated by a plus or minus, just one. A binomial could look like this, x minus 7. It has 2 terms, 1, 2. A trinomial has to have 3 terms, so maybe x squared plus 4x minus 5. That could be an example of a trinomial because there are 3 terms, 1, 2, 3. So now let's classify these two polynomials by both their degree and the number of terms. So for the first one, the degree, remember, is the highest exponent. The degree here is 2. That's because the highest exponent is 2. Remember, when we're classifying by degree, we use linear, quadratic, cubic. So this would be called a quadratic because the degree is 2. Now let's look at the terms. So here there are 1, 2, 3 terms. So the terms here, there are 3 of them, which we would call a trinomial. So nomial, meaning like terms. How many? 3. Try, that root word, try means 3. Let's look at the second example. For the second example, let's look at the degree first. Remember, the degree is the highest exponent. Here, there is no exponent written, but there is an x, so that means the degree here is 1. When the degree is 1, that's called a linear polynomial. Next, we can look at how many terms there are. So if we look at the terms, there are 2 terms, which means we would call this a binomial. Nomial meaning terms, bi, that root word, meaning 2. So 2 terms.